Okay, this will be the last video in our series of dealing with the Root 3 under the circumstance of single-phase loads on three-phase systems under balanced conditions. So let's analyze a particular problem with all of the information we've learned up until this point and see how we can work through it effectively. So let's say in this problem we have a Y source connected to a load. Once again, single-phase load on a three-phase system. This load is connected line to line, as you can see in the circuit diagram there. And let's apply some givens. We have a line voltage of 208 volts, and we have a current of 11 amps. Now you may be asking yourself, why didn't I give you the particular type of current for this problem? Why didn't I say phase current or line current? Well, let's review our previous video's flowchart to see why that's an insignificant element to discuss at this particular for this particular circuit. If we see that we have a Y source, we know with Y sources that the line current and the phase current match. They're equal. So it really doesn't matter if I tell you that it's line current or phase current. It's just current. So we're going to solve for power at the load. So moving along our flowchart, now that we understand the current is understood, we need to ask ourselves, what is the nature of this load? We can see in the circuit diagram that it is a line-to-line connected. It is not line to neutral. So we need to ask ourselves then the question, is the voltage that we've been supplied with matching the connection type of the load? If you see, we have line voltage, and our load is connected line to line, not connected line to neutral. So that means we do have a yes. Now from our previous work in the flowchart, we realized that if we can answer yes to that particular question, then Root 3 is not required in our power calculation. There's no need to convert voltage from one thing to another. We have the line voltage and we have a line-to-line connection. So we use the straight P equals VI power calculation, apply the givens to that formula, and do straight algebra. Very simple, very clean and tidy. We end up with this amount at the end. The big thing to recognize here is, did you realize as you were looking at this problem that Root 3 would not be involved? It's just as important to know when to use the Root 3 as when not to use the Root 3. And the evidence of this circuit diagram demonstrating line voltage and a line-to-line connection shows us that Root 3 is not required. And obviously, if you would have applied a Root 3 willy-nilly, just tacked it on somewhere to your equation, you would have gotten this one wrong. So keep sharp on these ones.